Oh, hey. If you take displacement and you take the derivative of it, you get velocity. If you take velocity and do the derivative, you get acceleration. So the application to kinematics of integrals is you could work backwards. If you have acceleration, you could work backwards to velocity, and you could work backwards. And we went back to the integration book because we missed something. So we get some information. We have acceleration given with an equation. Can you work backwards to create the original equation? And this is connected to something we've done already. Which is solving for C and D. So I'll give you guys a head start. How'd you do for the first step? What's the value of C? C is equal to 8. Because when time is 0, so if I plug in 0 for time, the velocity is 8, so C is equal to 8. Then our equation for velocity is t squared over 2 plus t plus 8. And what would the equation for displacement be? Well, we integrate again. So now we'll have t cubed over 3, but there was already a 2 on the bottom, plus t squared over 2 plus 8t plus d. And we're also told that the displacement is 0 when time is 0, so d, plug in 0 for t and 0 for s, and you'll get d is equal to 0. So t cubed over 6 plus t squared over 2 plus 8t plus 0. You wouldn't have to write that plus 0. Okay, here's the next one. What's going to be hard is you always have to think, which way am I moving? Am I taking the derivative, or do I need to integrate? So for this first one, you've got the velocity, you want to find the acceleration. Do you integrate or take the derivative? Derivative. So acceleration would be negative 10 meters per second squared. You could write it that way, or you can write it with the minus 2. Which seems reasonable since gravity is negative 9.8. This looks like it's just been rounded to negative 10. So if the initial displacement, what does this mean when they say initial? T is equal to 0. So when time is 0, we know that the initial displacement is 40 meters. If we want to find S, what would we have to do to find S? Integrate which one? Original V, so and when I plug in 0 for T and 40 for S, I get that C is 40. So S will be equal to 50T minus 5T squared plus 40. All right, put up some of the answers for this one. Got acceleration is 2T minus 4. Velocity, integrate that would be T squared minus 4T plus C. At T equals 0, V equals 3, so you could put in 3 and 0 for T, and you'll get C is equal to 3. So we get our velocity equation as t squared minus 4t plus 3, correct? Okay. And part B, displacement then would be the integral again, so we'll get, is it t squared over 2 or just t squared minus 4t? Trying to memorize it. Plus 3. And what was the initial displacement? S is 2. So then you would get d is 2. Because when t is 0, s is 2. And so there's your equation for displacement. Now to find out when it's at rest, that means your velocity is equal to 0. And if the velocity is equal to 0, then that means that we have t squared, is it minus 4t plus 3? So at t equals 1 second and at t equals 3 seconds, we have the particles at rest. Has anyone calculated these?
Yeah.
What are the,
3.333.
this one is the first two? 3 1/3 or 10 over 3? Is that what everybody got?
Yeah, I got that.
All right. Some definitions. Do you know the difference between, in English, displacement and distance? Okay. So if you take a ball and you throw it up 2 meters in the air again and you catch it at the same place, then we would say its displacement is 0. But since it's gone up 2 meters and down 2 meters, then its distance it's traveled is 4 meters. So if I were to drop this ball from 2 meters, right? It'd go down, up, down, up, down, up, down, up. What's easier to calculate in the end? It's going to be easier to calculate distance or displacement? Displacement. The displacement is, if I start at 2 meters, the displacement is 2 meters because it ended up on the floor. What's the distance it traveled? Grade 11 formula. Do you remember it? Yeah, sum to infinity. Because what's happening? It's going down, and then what percentage do you think it's bouncing? Yeah, I know, but look, what do you think? Best estimate. 75%? So we'll do 75. It'll be easier math. So it goes down 2 meters. Then it comes up 75%. You're saying 1.5 meters. Then it goes down 1.5 meters. Then it comes up 75% of 1.5. 1.125. Is that right? 0.75 times 1.5. Is that right? Okay, good. I'm not going to keep going. Because then it goes down 1.125, and then it would go up 3/4 of that, which would be 0.84. There we go. And down again, and down again, and down again. These both make infinite geometric sequences. Do you remember the formula? Remember seeing this formula? That if you have an infinite geometric sequence, that's term 1 over 1 minus r. There's actually two sequences here. If you count all the down distances, then you 2, 1.5, 1.125, and so on and so on. Then the sum to infinity would be, term 1 would be 2. 1 minus r was 3/4. You get a nice number of 8. Because we said 75%. So that's how much we're multiplying each time. If we started with 1.5, can you see that all the up distances, this is all the down distances, all the up distances would equal, mental math. If all the down distances are 8, all the up distances would be -2, 6. Because it's the same sequence, right? Just without the 2 at the beginning. So this ball will travel a distance of 14 meters, theoretically. You can either do this math this way, or you could just keep calculating as it's going. And at the end, anyways. Yeah, but same thing with the ball. If the world was ideal, the ball would keep bouncing forever. But it doesn't happen. But at that point, when the bounces are, like if you listen to them, there's a lot of bounces at the end. It'd be hard to count them. Oh, my golf ball with the Jets logo. What's that? I've laced it with poison. So if you touch it, you will die. Last 3 years, I've developed an immunity to that poison, so that's why I'm okay. So displacement will just be the integral, because the integral will take into account anything that's positive and negative, and just get you to figure out the displacement. If there's a place that's negative, you have to do the absolute value of those different things, because for example, if you had a graph like this, and you wanted to find the displacement from here to here, this part of it will say that part of it's going up. But this part of it will have a negative, meaning it's coming back down. And they may cancel each other out. And if you wanted to find the distance, you'll have to do what we did before and find out that point in between. And take whatever's below and make it positive, and whatever's above, you could keep the same. So that's where we'll stop. We'll do this question. We'll start these last two questions after your test. Oh, I've been recording for all the golf ball thing? Yeah. Oh no.